All right, let's continue with section 3.4 and the derivative. Okay, in example 1, let's consider that same graph that we were just looking at with Desmos, 1/4 x squared. And in part A, we're going to find the slope and equation of the secant line through these two separate points. Okay, and we'll go back and we'll check and make sure that our answer matches what Desmos is telling us. And then we're going to do the tangent line as well. Okay, so for the secant line, remember that that's two separate points, okay? And really, as long as we know where a comma f of a is, and then a plus h, but we're just going to consider it as just some completely separate point, as long as I know the exact x, y components of each of these that are located on the graph, I can just find out the equation of the line that goes through them, just like we would if we were in just like a linear equations section. Okay, so for x equals -1, we need to find out f of -1. We need to find out the y part. Okay, so f of -1, go to the function. It's 1/4 times -1 squared. Make sure you do the order of operations. So the squaring has to come first. That's going to be 1/4 times -1 squared, which is +1. And then this gives us 1/4. So the point that's on the graph that we need to use is -1 comma, and when we found out the y part, it came out 1/4. Okay, so we'll use that point. We also need to find out the y part of the other point. So for f of 2, plug it into the function, 1/4 times 2 squared. Order of operations, so the 2 gets squared first. So now that's 1/4 times 4, which comes out 1. So then the other point that we're interested in is 2 comma 1. Okay, now we have that formula up there for the slope of the secant line, but really all you have to do is just imagine that you're in the linear functions section and just find the equation of the line that goes through those 2 points. Okay, and so I'm going to kind of go old school here, and I'm going to say, well, if I have m, remember that that's y2 minus y1 over x2 minus x1. Okay, just like the old days. That's literally what the average rate of change function is. And so if we think of this one as like, we could say that this is the x2 and the y2, and then this one is the x1 and the y1. We can work out the slope formula, which is really just that average rate of change formula. So y2 minus y1, that's going to be 1 minus 1/4 divided by x2 minus x1, so that's going to be 2 minus -1. Okay, so a little bit of a hassle here. 1 minus 1/4, I guess that's 4/4 minus 1/4. So we can write it as 3/4 divided by 2, and that'll be +1, so that's 3. Okay, so it would be a shame if you ran into this fraction on top of a fraction situation, and this is the reason why you missed the problem. So the way that I recommend working with this to avoid even needing a calculator is write this divide by 3 as divided by like 3/1. And then now it's really clear that it's like a fraction divided by a fraction. What happens when you divide by a fraction? Well, it's the same as flip and multiply. So write that 3/1 as times 1/3. That's the way that I've always done it. That really helps me because now we can see that those 3/3s can reduce and the result is just 1/4. So that's pretty nice. So I didn't need to use a calculator, and we can actually take care of that stacked fraction just using some, just a little trick there to help us simplify it. Okay, so there's the slope. The slope of these, between these 2 points. And so then remember to use the point slope form. Y minus y1 equals m times x minus x1. Remember the good old days? That's all we're doing, finding the equation of a line through 2 points. Okay, so y minus, okay, now it doesn't matter which one you call which, but I guess I already labeled this as x1 and y1. So y minus 1/4 equals m that we just found, 1/4 times x minus x1. So there's the -1. Okay, let's continue our work over here. Y minus 1/4 equals, so that'll be x plus 1 in there. And let's distribute the 1/4. So we get 1/4 x plus 1/4. And then if we add this 1/4 to get y by itself, we will have the answer y equals 1/4 x. Okay, so plus 1/4 plus 1/4 is 2/4, which reduces to 1/2. So that should be the equation of the secant line that goes through this function for x values of -1 and 2. And so let's check that. Let's go back. So we've got 1/4 x plus 1/2. Let's go back to our graph here. And so we started with an x value. What was the first one? X equals -1. So I'm going to choose that to be like the a. So if I set a as -1, and then the second point was 2. Okay, so the way that this is set up is it's like a and then a plus h. So I guess if x equals -1 is the a, to get to 2, I got to go -1 plus 3, right? So if I set the h to be 3, -1 plus 3 gives me 2. Okay, so then 2 comma f of -2, or 2 comma f of 2 comes out 1. So here's the line right there, and it looks like everything's pretty good, because if we just worked out the slope there, 0.25, yeah, that's 1/4. And then for this secant line right here, looks like it's got a y-intercept of 0.5, which is 1/2. Okay, so yeah, everything worked out, and that's the secant line from those 2 points. Okay, looking good. Let's go ahead and do part B now, the slope of the and the equation of the tangent line at x equals -1. Okay, so different kind of topic here. For a tangent line, we need to make sure that we work out that instantaneous rate of change. So that's going to be the limit definition. Okay, so this is pretty much like the a is -1 here. So let's work it out, the slope. We're going to have to work out the limit as h approaches 0. And I'll go ahead and write out the whole thing. So we're doing this thing here. Okay, we're doing this thing here. Limit as h goes to 0 of f of a plus h, f of a plus h minus f of a all over h. So let's plug these things in. Okay, the limit as h goes to 0. So a is -1. So we're going to go f of -1 plus h minus f of -1 over h. Okay, make sure you write limit each time. Okay, now f of -1 plus h. So that's the whole input. So 1/4 times input squared. 1/4 times -1 plus h squared minus, so f of -1. So the -1 is the input. It's got to be the whole function again, 1/4 -1 squared all over h. Okay, so as we've seen, these take a little bit of work to simplify, so let's keep going. The limit as h goes to 0. So the 1/4, I'll kind of just leave it alone for now. -1 plus h squared. That's a little bit weird to deal with. I would rather write that as h minus 1. That's the same as -1 plus h. And since it's squared, let's go ahead and write it twice. Okay, minus 1/4 times -1 squared, which is now +1. So notice how I'm kind of just going a little bit at a time to clean this up. I don't want to skip too many steps, but I want to just clean this up piece by piece. Okay, let's leave that 1/4 out there. Now let's FOIL this out. So h times h is h squared. Then we'll have minus h, and minus another h is minus 2h. And then -1 times -1 is +1. Okay, now over here, minus 1/4 times +1 is just minus 1/4 over h. Okay, so now working this out, we can distribute this 1/4 in here. So we'll have 1/4 h squared minus, okay, 1/4 times -2. So that's 2/4, which reduces to 1/2. So that's minus 1/2 So 1/2 h. And then 1/4 times 1 is plus 1/4. And then there's that minus 1/4. And that's looking good. I'm always hoping that something like this happens because now we can see that plus 1/4 and minus 1/4 will cancel. So let's keep going. Limit as h goes to 0. Okay, and so we've got, notice that those 1/4 cancel, and so all that's left on top are things that have an h in it. And remember, the whole goal is to see if we can get this to factor and cancel and get rid of that h divide by 0 problem. So let's go ahead and write that as an h can factor out, and we have 1/4 h minus 1/2. Okay, so we factored the h out, divide by h. Now those h's can cancel, which is a pretty satisfying moment in the whole process because we know that we're almost done. Okay, so now we just have this part, and now we can go ahead and use direct substitution. So plug in the 0 for h, 1/4 times 0 minus 1/2, and that's gone, and we get negative 1/2. Okay, what did we just find? Because that was a lot of work. Okay, this was the slope of the tangent. Okay, so all of that work gave us the slope of the tangent line. Okay, so thinking about how you find the equation of a line, remember that you need a point and a slope. Okay, so we need, and I'll write that down. That's something that we talked about in the past, but remember that we need a point and a slope to find the equation of a line. Okay, we've got the slope, there it is, that negative 1/2, but we need a point. Okay, and just like we did on the previous problem where we had to plug in those x values into the function to find out the corresponding points, we have to do that with this as well. And we already know what f of negative 1 is, but for the point, let's go ahead and write it. We need f of negative 1. So that's got to be, the function is 1/4 times the input squared. Okay, so whenever you're doing this, if they didn't give you the whole point that's on the function, they just gave you an x value, you have to take that x value and plug it in to find out the y value. So you know what the whole x comma y point is. Okay, so we already had this one from before, but this is 1/4 times positive 1, which is 1/4. And so anyways, we do have a point of negative 1 comma 1/4. So this is the location where the tangent line is going to just touch the graph. Okay, so now let's work it out as y minus y1 equals m times x minus x1, just like the old days. And we use the point and the slope that we're given. So y minus, okay, so that's going to be 1/4. Okay, the y part of that point. And then the m that we found, the negative 1/2, times x minus negative 1, the x part of the point. So that's y minus 1/4 equals negative 1/2. That'll become x plus 1 in there. Let's continue. Almost done here. Y minus 1/4 equals negative 1/2. So we're distributing this negative 1/2 in. And then negative 1/2 x, and then minus 1/2. Okay, and then finally, let's add this 1/4 to both sides. And we get y equals negative 1/2 x. Okay, so negative 1/2 plus 1/4, maybe do some scratch work. Negative 1/2 is negative 2/4 plus 1/4. So that's going to be negative 1/4 minus 1/4. And there we go. That is the equation of the tangent line to this graph at x equals negative 1. And let's go back to Desmos real quick and make sure that that's actually accurate. Okay, so we got negative 1/2 x minus 1/4. Let's take a look. Okay, so we picked an a value. We're using negative 1, but this time we're doing the tangent line. So this is where h goes to 0, right there. Okay, now Desmos breaks when we try to do it, but look at that slope right there. Negative 0.475. It looks like it's getting to be negative 1/2. but it's going to tell us undefined. So let's go down, and here is the slope of the tangent line. And again, this is some fancy notation that we're going to talk about in just a second. But yeah, negative 0.5. So that's the negative 1/2 that we got for all of that work to find that slope of the tangent line. There's the negative 1/2. Okay, and if I turn on the tangent line right there, what is that y-intercept? Negative 0.25. Is that what we got? Negative 1/4. Looks good. That's the same as negative 0.25. So there is the tangent line. And we did all of the work algebraically, but we can go ahead and confirm with our little Desmos simulation right there. All right, awesome stuff. I'll go ahead and make a separate video to pick up on the next page.